Hello and welcome to Team Pending's Reversi project. I'm Michelle and this is Summer, and today we will be explaining to you our project and how it works. So first, some interesting things about our program. We've actually included sound bites primarily for when a piece is flipped, like when a player places a tile or when the computer places a tile, and a few other sound bites in other locations too. And also, instead of leaving playable moves blank as if they were just any other empty tile, we've actually shown the wherever you can go using a question mark. So I guess Summer will let you show you with on the screen here. So as you can see, every place where the black player can currently go is stored on the display array as a question mark. So now we actually begin the process of playing the game. The first thing in each round is that it goes through and it clears all the previous question marks off the board. That's just done using a simple loop. The second thing it does, as we've seen here, is that it goes through and finds all the moves for the current player, which in this case is black. The way it does that is that it goes in each of the 8 directions and checks to see what tile is in the next immediate direction. So if it's the opponent's tile, it will look in the next one, at the next tile in that direction. If it's the player's, if it's next, or if it's out of bounds, it will stop the search and go to the next direction. Or if the tile is empty, it will place an X or a question mark at that spot and continue on to the next direction. Also, find moves returns whether or not a move was found, so that way we can determine whether or not we need to skip the user or the computer's turn. Next, we display board, which, as it's already been done here, done with a simple loop again, and now we get player input. First, it asks for the row and the column, and checks to see in bounds, if that's in bounds. So if I enter 9, it's not going to take that, or if I enter something negative, it's not going to take that either. So let's say we'll move at 3, 4. That seems like a good spot to go. And once user enters a valid row or column, it will calculate the index and ensure that it's a question mark at that location. And then once it's ensured that's valid, it will call the flip function. A flip is very similar to find moves, in that it goes in all 8 directions, searching to see what the tile in that direction is. The one difference is that instead of looking for an empty tile, it's actually looking for the player's tile. So that way, once it finds the player's tile, it will go back in the opposite direction, and as it does that, it will flip the tile. So here I placed the tile at 3, 4. It went, which is above a black tile. So when it was searching down, it found the black tile at 5, 4, and then it started going back up, and along the way up, it flipped the tile at 4, 4. That is one entire move. So now we're going to talk about the computer's turn, which, as it's already done. The computer checks for, computer has a strategy. It checks for corners, and if it finds a corner, it will take that corner. Now, if there are multiple corners available, it will choose one randomly. If there are no corners, it does the same thing for sides. That is, if there's a side, it will take it. If there's multiple sides, it will take a random side. If there are no corners or sides, it takes a random move available. And here it happened to choose 3, 5, which, it didn't have any corners or sides, so it didn't really choose any of those. So let's see if we can try to sway the computer into choosing a side. So let's go for, let's go for 2, 6. Alright, we still don't have any sides that the computer could take, so let's go for, what did you say, Summer?
I'll just take 3, 2 for randomly.
Okay, yeah, sure, 3, 2. So as we see, the computer had a side at 1, 7, and instead of choosing any of the other question marks on the board, it selected 1, 7. So I guess we'll just play through a couple of more moves, I suppose. Let's go for 6, 6. Oh, really quickly, I wanted to show that it wouldn't take a move that wasn't question mark. So let's just try 1-1. So that works too. Let's go for, I don't know, 3-6. Okay. Let's try 2-7. All right. Let's take one. Oh wait, what?
We have a corner to take.
Oh yeah, we have a corner to take. Let's take it. Ta-da! Now let's see. I guess we can just start taking that side. So we've played through a few rounds. I think we're going to end the video here, but we'll cut back to when the game is over so that you can see how the end game works, and we can explain that too. So bye-bye. So welcome back. We have about 8-7 moves left. Someone's going to continue playing the game while I talk to you about in-game. In-game is our final function of the program. Once there are no turns left, in-game is called. And basically what it does is it's a loop to count tiles. And so if we find a black tile, we'll count that to a black counter, or a white tile to a white counter. And then once all the tiles have been counted and the whole board's been gone through, it will compare the number of tiles from each team, and then it will display the winner based on that. So it looks like we won this game, and that is our program. Just a quick aside, Seven is busy today. She is writing the user manual, and so other than that, our project is done. So thanks for watching, and goodbye.